So for question 14, part B, state how polarized transverse wave differs from unpolarized transverse wave. I have a diagram here that shows the concept of an unpolarized light passing through a polarizer, and after passing through the polarizer becomes the light becomes polarized in one plane. So to answer this question, to describe polarized transverse wave, you can just simply say that the oscillations of the particles are being confined to a fixed plane perpendicular to the direction of propagation. On the other hand, an unpolarized wave, there is no such restriction on how the plane of the oscillation of the particles will be. But see, the question asks for what will be the amplitude after it passed through Q. You realize that the light wave that passed through P will become polarized in a certain plane, and Q, when placed in this manner, the axis of the polarizer Q is parallel to that of P. That means that all the light from P will be able to pass through Q. So the amplitude that pass through Q will be, in fact, A. And because the amplitude is A, therefore the intensity will also be I. For part 3, what is the relationship between intensity and amplitude? So if you refer to your notes earlier, intensity is proportional to the amplitude square. And so we can write down I is equal to Ka square, where K is the constant of proportionality. For part D, now polaroid Q is being turned, and you are supposed to deduce what will be the amplitude and intensity of the light that will pass through polaroid Q. So if polaroid Q is being turned through an angle theta of 180 degrees, you can see from the diagram, you can imagine that if it's being turned 180 degrees, polaroid P and polaroid Q, the axis of polarization will be parallel to each other again. So the amount of light that will pass through will also be amplitude A, since P and Q are the axis of polarization are parallel to each other, and therefore the intensity will also be I. However, if Q is 90 degrees, that means it's perpendicular to the axis of P, then no light will be able to pass through, so the amplitude will be 0, and therefore the intensity will also be 0. What happens if the angle between P and Q, the axis of polarization between P and Q is 60 degrees to each other? So in this case, you got to think about what component of the amplitude will be able to pass through Q. So I can imagine after passing through P, I have an amplitude A. Now I have the axis of polarization for Q in this direction. So what I can do with amplitude A is that I break this down into two components. So one component will be parallel to the axis of Q. The other component will be perpendicular to the axis of Q. So the amount that will pass through will then be A cosine theta. So the amplitude that will pass through Q will in fact be A cosine theta. And if we work that out, cosine theta is half. So the amplitude that pass through Q will be A over 2. And because intensity is proportional to intensity square, so the intensity that now pass through is Ka square, or rather K bracket A over 2 square. And that you can deduce will be 1/4 of the intensity. So that completes question 14.